guys, section 6.6 today, rational exponents. Remember from before that the word rational means to be able to write it as a fraction, and exponents are exponents. Problem similar to what we've been doing here. Square root of x to the 8th is x to the 4th. But how did we get that? Okay, we divided the exponent 8 by the root 2, square root meaning the second root, and we got 4. So we could write that as x to the 8 over 2 and still get the same answer. And that's what we're going to be working with today. We're writing them as a fraction, our exponents as a fraction, where the top part of that fraction is the power and the bottom number is our root. Okay? Examples here. We have the 5th root of x squared. So the squared is our power, it goes on top, 2. 5 is our root number, 5th root, goes on the bottom, x to the 2/5. Then we have x to the 3/7. Okay, the 3 is our power, so it goes on top of it there in the power, and the 7 is on bottom, that's our root, 7th root, so we can go forwards and backwards here, guys. And for whatever reason, sometimes this trips kids up. We have x to the 1/4. Okay, the number on the bottom is our root, 4th root of x to the 1st. And if you want to put the little 1 on there to help you out, that's fine too. Okay, so you guys got a couple seconds over here. Go ahead and try these. Hit pause, and then try these. And if you couldn't read my handwriting, that was supposed to be a 4. If you had a 9, that'd be fine. Okay, then this one, we would have the cube root of x squared. And this one is the square root of x to the 3rd. And if you want to put that 2 out in front of it, I'd be okay with that as well. Remember from earlier in the year, when we have a negative exponent, it means to do the reciprocal. So x to the negative first power is 1 over x, or 1 over x to the 1st. So if I did 16 to the negative 1/4, that would be the same as 1 over 16 to the positive 1/4 exponent now. Taking what I learned today, the bottom number is my root, so 4th root of 16 to the 1st. And if you don't know your 4th roots, you can type it into the calculator. 16 to the, use parentheses here, 1 divided by 4. And we should get 2. So we're 1 over 2, or 1/2. Alright, we can do the same thing here with this one, 27 to the 2/3, okay? So we could write this as in a couple different ways. We could go 27 squared, and then do the cube root of that. But I think it's easier to do the roots first, because that's going to make this smaller, and then I can do exponents of small numbers a lot easier than I could do the roots of the big numbers. If you did 27 squared, it's going to get really big, and then you're not going to know off the top of your head the cube root of that number. Whereas if I do it this way, do the root first, it's likely that I'll be able to do a lot of this stuff in my head or on paper and pencil. Okay, so do the root first. I think it makes it easier. Example, 16 to the 3/2. That's going to be square root of 16, and then we want to cube that. Okay? So that's going to be the square root of 16 is 4, and 4 to the 3rd is 4 times 4 is 16 times 4 again is 64. If I would have gone the other way and did 16 cubed and then square root that, 16 to the 3rd is going to be 4,096. Would you know off the top of your head the square root of 4,096 is 64? Me either. But I have to type it in, and that's what I would get. Much quicker to go this way. Okay, next part of notes. Alright, more of the same stuff here. Just another example problem. Okay, do the root first. 5th root of 32 is going to be 2, and then 2 to the 3rd is 8. We'll skip that one. We've done enough of those. Multiplying. When I multiply the common bases here with the exponents, I get to add my exponents. So a to the 2/7 times a to the 4/7, I get to add 2/7 plus 4/7. We're going back to junior high math here, kids. We're adding fractions today. 2/7 and 4/7, it's going to be 6/7. Alright? What happens if I have negative exponents, and how is that going to play into multiplying? X to the negative 2/3. Okay, we're going to flip it upside down. 1 over x to the positive 2/3. Okay? Now, this is the cube root of x squared. And that's still doing a root down here. So that's no roots on the bottom. That's our rule. So we need to fix that. We need to have whole number exponents on the bottom. Whole number exponents on the bottom. Okay? So 2/3, the closest whole number there is going to be 1. What fraction am I missing to get to 1? If I have 2/3, I need 1/3. So I multiply top and bottom by 1/3. So here's where the multiplying comes in. And now I would get to add my exponents. 2/3 plus 1/3 is going to be 3/3 on the bottom, which is just x to the first, or x, however you want to write that. And on the top we got x to the 1/3. So it doesn't look nicer or more simplified than this, or even that, but it is. But it is. Okay, some trial problems for you here. Hit pause and give these a shot. Alright, so when we add these up, 1/4 and 9/4 is going to be x to the 10/4, which is reducible. Is that a word? Reducible? To 5/2. And then over here, x to the negative 4/5, we're going to have 1 over x to the 4/5. Okay, what fraction am I missing? I'm missing 1/5. So times x to the 1/5, and we'll get x to the 1/5 over x to the 5/5, which is x to the first. Hanging in there? Good. Okay, now this is going to look messy, but it's not that bad. Okay, the toughest part of this stuff here is the fractions. It's the fractions. Okay, I'm going to cover up part of it here so we don't get too distracted and think that it's going to be too tough. Okay, so we're simplifying and we get these roots over roots. Okay, the trick here is to look at the bottom number. We're going to try to write this with the same big number. Okay, and it's the smaller number is probably going to be your big hint as to what number I should be looking for. So this is the 4th root of 27 over the 4th root of 3. So 3 is the small number, so hint, hint, I should be able to write this 27 as a 3. And I can, it's 3 to the 3rd. 3 to the 3rd is going to be 27. Okay, so now I'm going to rewrite this form in rational exponent form. So my power is 3, my root is 4, 3 to the 3/4 over 3 to the 1/4. Okay, think back to your exponent properties. When you're dividing, we get to subtract exponents. And 3/4 minus 1/4 is 2/4, which is a half. 3 to the 1/2. 3 to the 1/2 power. Okay, what happens when those roots aren't exactly the same? Okay, I have the 8th root of 16 over the 6th root of 2. 2 is still my hint. I want to rewrite 16 as a 2. 16 is going to be 2 to the 4th. Okay, it's going to be 2 to the 4th power. And now I rewrite these in fraction form. 2 to the 4/8 and 2 to the 1/6. Okay, I can simplify 4/8 to 1/2. So 2 to the 1/2 over 2 to the 1/6. We're going to subtract our exponents. 1/2 minus 1/6. Think back to junior high, kids. Got to have a common denominator. A common denominator, okay? So 1/2 I could rewrite as 3/6, and now I can subtract, get 2 to the 2/6, which is 2 to the 1/3 power. So it all worked out in the end. Alright? So the big key here is to be able to rewrite the big number as a multiple or as an exponent form of the smaller number there. And then change them into rational exponent form, and then use our exponent properties to simplify from there. Again, the toughest part is adding and subtracting these fractions, which is junior high math. The Algebra 2 part is actually pretty easy. Conjugates again. Bum bum bum. Okay? Again, kind of like, I think we did it yesterday. Okay? But today they're going to be written with the rational exponent form. X to the 1/2 minus 2 over 3 times x to the 1/2 plus 2. If I were to write that in root form, that would have been the square root of x minus 2 over 3 times the square root of x plus 2. And we would have done the conjugate to simplify this expression from yesterday. Okay, so we'll keep it in this form, rational exponent form, but we're just going to use the conjugate, which is the same as our denominator, but with a different sign. So we're going to have 3 times x to the 1/2 minus 2, top and bottom. Okay? And then we're going to FOIL, or multiply this out, x to the 1/2 times 3 x to the 1/2. That's going to have 3 times x to the 1/2 squared. X to the 1/2 times a negative 2, so minus 2x to the 1/2. Negative 2 times 3x to the 1/2, so negative 2 times 3 is going to be negative 6x to the 1/2 over here. And a negative 2 times a negative 2 is a positive 4. Across the bottom, 3x to the 1/2 times 3x to the 1/2 is 3x to the 1/2 squared. Okay, times the negative 2 is going to give you a negative 6x to the 1/2. Plus 2 times 3 is going to be a positive, or a plus 6x to the 1/2. So we have a negative 1 and a positive 1. Those will cancel out. And then the plus 2 times the minus 2 is going to be a negative 4. So on the bottom we had two things cancel out. On the top we can simplify. Okay? X to the 1/2 squared is just going to be x to the first. Use your exponent properties. We multiply 1/2 times 2, and it's going to be x to the first. I have a negative 2 and a negative 6. That's going to be negative 8 x to the 1/2 plus our 4 on the top. On the bottom I had 3x to the 1/2 times itself, so 3 times 3 is 9. X to the 1/2 times x to the 1/2 is x to the first. My middle part canceled. And then I had this minus 4. And that's as far as we'll take it. Okay? If you were in class today, you know that we have a different type of assignment. Different in that it's not odds or evens or alls. We're going by threes. We got 18 through 60 by threes. So 18, 21, 24, 27, ... You can figure it out after that. Stop at 60. Alright? Best of luck!